Word-Konferenz. Freut mich sehr, dass ihr alle da seid. Bei sonnigem Wetter haben wir Wichtigeres zu tun, das ist auch gut so. Wir freuen uns jetzt auf einen tollen Gast. Paul Lamere ist da. Er ist ja eigentlich beim Echo Nest in Massachusetts und dort geht es natürlich hauptsächlich um Data Mining. Der Mann ist seit 30 Jahren in der Softwareentwicklung. Die letzten 15 Jahre hat er sich nur auf Musik konzentriert und es geht einfach bei ihm um die Leidenschaft, Musik zu entdecken, zu verstehen und für die User, für die Hörer brauchbar zu machen. Und das macht diese Firma seit vielen Jahren und er ist der Director dieser Firma. Und diese Firma ist sehr gefragt. Im Frühjahr wurde sie ja von Spotify gekauft und unter das Dach genommen. Und die wissen schon genau, warum sie sich diese Truppe geholt haben. Und ich freue mich sehr, dass Paul jetzt hier ist und uns ein bisschen was erzählen wird zu Data Mining Music, wie das Ganze vonstatten geht und uns ein bisschen hinter die Kulissen schauen lässt. So, ich würde euch bitten, ihn mit Applaus zu empfangen. Paul Lamere hier bei der Berlin Music Week.
Thanks a lot. I don't know what she said. I hope it was not too bad. So I'm really excited to be here. This is my second trip to Berlin. It's a great city. It's a really creative city, a really musical city. It's a fun place to be. So I'm pretty excited. Thank you for inviting me, whoever was in charge of doing that. So I'm Paul Lamere. I work at a company called the Echo Nest. The Echo Nest is a music intelligence company, and we've been using big data to help improve the music listening experience for people across all sorts of music services for almost 10 years now. And pretty exciting news for us in the last 6 months, we were purchased by Spotify. So we're sort of doubling down and focusing on making the music listening experience for Spotify listeners be the best in the world. And we do this by using lots and lots of big data. So today I'm going to be talking about how we can use big data to help improve the music listening experience for people. But first, I think we want to take a look at where we are in the world of music and technology. When I was coming of age musically, this was the exciting new music technology, the Sony Walkman. And this was the first time you could take your music with you when you're going for a walk or whatever. Portable music, you could put 10 songs in your pocket. And this really, really transformed how we listen to music. Now, let's fast forward to today. We've gone from having 10 songs in our pocket to having, through music subscription services like Spotify or Deezer or RDO, having 10 million, 20 million, or 30 million songs in our pocket. So it's been this incredible transformation about how we listen to music, which is pretty awesome. So a typical listener is now just a couple of taps away from being able to listen to just about any recorded music that in the world. So it's totally awesome. But one of the problems is you can't really just put a search box in front of 30 million songs and expect people to have a good music listening experience. This young man here, he's kind of bummed out. He has 30 million songs in his pocket and he doesn't know what to do with them. He listened to his emo stuff and then he was done. So what we want to do is try to help improve the music listening experience for people. And we can do this, luckily, along with these 30 million songs that have come to today, a whole lot of data has come as well. So I'm going to talk today about how we can use this data to help people understand music better, to help them to explore and organize their music, help them to discover new music, help them to interact with music, and maybe even help them to create new music. So I'm going to be talking about 4 different kinds of data. First of all, it's music metadata. This is the basic facts about music. Then there's cultural data. This is what people think about music, what people say about music. There's listener data. This is how people interact with music. And finally, there's acoustic data. This is data about the music itself, derived directly from the data. So for each of these data sets, I'm going to talk about some of the issues around the data. I'm also going to talk about some of the things that you can do with this data. And then I'm going to show some examples of how you can use this data to do some novel things. And because I come from the music hacker world, the things that I like to show are maybe less mainstream, less about having a business model around the data, but more about doing something fun and creative with the data. So let's get right to it. First type of data is music metadata. This is the basic facts around the data. I see Robert Kay here. He's a master of music metadata. He runs Music Brains. Music metadata is all about understanding who the artists are, what all the albums they have, what all the tracks are. At the Echo Nest, we've been tracking about 2.5 million artists, and this means not just their names, but their bios, their images, how long they've been active, where they're from, their band members, their genres. Music metadata includes information about albums, such as when they were released, their genres, the track lists, producers, the labels, and then 40 million, we have data on 40 million tracks, and track information is, who's all the performance on it, duration, stuff. So basic facts around data. So if you're building any kind of music service, this is sort of your basic plumbing. You need to have this data, you need to have it right. And it's sort of, basic nuts and bolts, but it's not so easy. There's a lot of really complicated and crazy stuff in this data. And just to give you a little example of this, here's a very basic music query. What are the songs on the album White Christmas by Bing Crosby? Now, it's pretty basic. What could be easier than that? Well, it turns out it's quite a bit harder, because Bing Crosby actually has about 40 albums that are called White Christmas. They are all different. They have different tracks. They have different performers on them. They have different album art. And so to answer the question, what are the tracks in White Christmas, there's no right answer. There's no single answer. So, Bing Crosby, he had a goose that laid the golden egg, which is White Christmas, and he went to that goose every year, as far as I can tell. So music metadata, it's hard, it's sloppy, but still, it's really important. So I'm going to show a couple hacks just to get us started, a very, very simple, small data kind of hack built around music metadata. So someone posted this question to Quora: are band names getting longer? Now, clearly, this is a really important question for us to answer. So everyone needs to know the answer to this. So this guy, Zach Davidson, he came along and offered his answer. Now, first, Zach, he gives his bio. He says, I named both my bands. So clearly, he has some expertise in this area. And he gives this really long, involved answer. But basically, he said, yes, they've been getting longer, but very, very gradually. But because we come from the data world, let's see if we can use some data to answer this question. And it turns out it's really easy to do this. The actual code to do this is actually shorter than Zach's answer. Only thing you have to do is find the top 500 artists for each 5-year window, find the length of their names, calculate the average, and you're done. So the question is, have band names been getting longer? Raise your hand if you think, yes, band names have indeed been getting longer. All right, well, let's check the answer. Well, the answer is actually no, they have not been getting longer. So here's a chart here. The top are 1950s, the bottoms are the 2010s, and you can sort of see there's a general trend of band names getting shorter. And in fact, the longest average 5-year span for band names is 1955 to 1959, where they're about 2 characters longer than any other year. And so we say, hey, what's going on during this period of time? We can sort of look at some of the band names from 1955 to 59, and we have bands like Van McCoy and the Soul City Symphony Orchestra, or Academy of St. Martin's in the Fields. So you see there's sort of this general naming pattern at the time of band name, band leader, and the band name. And so that's why back in 1955, the band names were so long. But of course, we can't just stop here. We have to say, hey, what are the longest band names? And my favorite and the longest that I've encountered is Tim and the Sam Band with Tim and Sam. So clearly some good marquee work there. And so that's it, longest band names. And here's one more quick hack around music metadata. And this is a hack called Acrostify. The idea is it will let you embed secret messages inside your Spotify playlists. So you guys know what an acrostic is. It's a block of text where the first letter in each line spells out a message. So this lets you do the same, but with playlists. So say you're courting a young lady and she's into country music. You can give her a little secret message in a playlist. Acrostify will then make a playlist with I love you with the first letter in each thing. So a quick hack built around metadata. You can do this sort of thing if you have really good search around your tracks and genre and that sort of thing. So quick tour through music metadata. Next, we're going to talk about cultural data. So this is data around what people think about music. or what people are saying about music. So here's your typical pitchfork review for Daft Punk's Random Access Memories album. And you can see here they have a score, but they have a lot of descriptive text. And if you start looking at this text, you'll see lots of descriptive words that come out around Daft Punk. So we see electronica 1990s, so these are descriptive words describing the type of music that they make. And we see words like novelty, funny, fun, hit, playfulness, surprise, positive, life-altering. So these are adjectives, adverbs that have some really positive sentiment about the band, and they're descriptive in some way. And there's also some negative terms like negative and inert and forgettable and puzzlement. And this is all just driven from one paragraph of one review for one album. So if you imagine taking all the words from all of this review and then add to it all of the other reviews for this particular Daft Punk album, don't stop there, but then go to all the MP3 blogs and every other place that people are writing about this album and pull together all the words, you start to get a really, really rich, nuanced description of what this album is all about. So this is really one of the core technologies of the EchoNest, is to do this data mining of web conversations about music. So we have Google scale crawlers that crawl all the music sites on the web, every music blog, every music review site, any place that people are experiencing music online, taking all the words, crawling them, doing some natural language processing and machine learning around that text to get an idea of what this global conversation is about music. So we get a notion of sentiment about artists. We get a notion about which artists are getting a lot of chatter. And then we can start to use these descriptive terms to do things like find out which artists are similar to another, because artists that are described with the same sort of words and phrases tend to be similar, and artists that have disjoint sets of these phrases are typically not similar. So for example, you see here Britney Spears is probably more similar to Evanescence than to Daft Punk and Deadmau5, just based on looking at sort of the overlapping terms, whereas Daft Punk and Deadmau5 are more similar to each other. So artist similarity driven from this cultural data, this is really, really important kind of data for doing anything like music recommendations and playlisting, because one of the nice things around cultural similarity is it's independent of a lot of the things that you see with these popularity-based metrics. And so one of the things I like to do is to use this artist similarity data to do interesting things around music discovery. So one of the things I do is take all of this artist similarity data and connect all of these artists to their nearest neighbors and essentially build a big artist graph. So here's a visualization of an artist graph made by some researchers at Stanford. This is about 10,000 artists shown here. We typically take an artist, make an artist graph of 100,000 or 1 million artists, all positioned close to their nearest neighbors. Then you can do interesting things with this graph, like finding paths between artists. So for instance, you may start with one particular artist and slowly generate a playlist that will bring you to another artist. And this is, there's an example of doing this. It's called Boil the Frog. And so boil the frog, you may have heard of this old story about boiling the frog. If you take a frog and you put it in hot water, it will jump right out. But if you put it in cold water, it will stay there. And if you gradually heat up the pot, the frog won't notice and it won't jump out, and you can boil the frog and have frog stew. So the idea with Boil the Frog is to do that same sort of thing, but do it musically, to take somebody gradually from one style of music to another. So for instance, my 16-year-old daughter was a big Justin Bieber fan. If I want her to get her listening to some other kind of music like Elvis Presley, I can make a Boil the Frog playlist that's going to find a path from Justin Bieber to Elvis Presley, but very, very, very gradually take her from one style of music to another. So she may find herself after 15 songs listening to a completely different kind of music. So when I run this Justin Bieber to Elvis Presley playlist, I get this 15-song playlist. Starts with Justin Bieber, goes to Cody Simpson and Big Time Rush, and then to Jonas Brothers, McFly, the All-American Rejects, Yellow Card, Billy Talent, AFI, Anti-Flag, Social Distortion, Mike Ness, Stray Cats, Eddie Cochran, and then finally to Elvis Presley. So you can try this. This is all online. So next thing we can do with these similarity graphs is start to look at these local clusters in here, and we start to see these are really where some of our genres live. And so it's interesting that we can sort of derive the genre space just by looking at this artist connectivity. So there's certain artists, like country artists, that are close together. We can start to note that those particular artists are often described as country or alt-country and derive a really, really rich set of genres. So this next demo is called Spotify Popcorn, and it's a tool for exploring about 1,200 or so genres that we've identified in this genre space in this way. And in this demo, you'll see sort of browsing around the different genre spaces. The genres are sort of positioned based on all the genre similarity, but when I click on something, it wants to reorganize the space around that particular genre, so that's why everything sort of pops and jiggles and sort of looks like popping popcorn. And I can click on different genres and hear examples of the different kind of music. So hopefully our audio will work and we'll give it a try. Born into religion and a third world war, spitting blood in the face of God. Pretty baby, I have in store for you. Nowhere. I want control. I got to get control. No regrets. That's me. I want complete control. I'm pulling up dog shit. All right, so that gives you sort of a quick tour through cultural data and how you can use this for doing things like discovery and organization and all sorts of things like that. So next up is listener data. So this is looking at how people are interacting with music. So who listened to what and when. So any music subscription service out there right now, whenever you click play on a song, it's collecting who you are, what song you just clicked play on, or maybe you skipped it, or maybe you did a thumbs up or whatever. It collects all that action data and timestamps that data. So a music subscription service with about 10 million listeners maybe generates about 1 billion of these data points a week. So that's a huge amount of data, and there's all sorts of really, really interesting information in there. So of course, music services can use this data to derive charts. So what are the most popular artists overall, or what are the most popular artists in Berlin this week? You can also use it for creating recommendation algorithms. So the typical people who listen to this also listen to that kind of algorithm is driven off of this data. So this is really, really important data for just about any music service. Well, one of the things I'm really interested in looking at is how to use this data to do things like identify artists that have really, really passionate fans. So I think fan passion is a good way to see which artists are really, really important artists. So artists with very passionate fans, those fans are more likely to drive further to go to concerts. They're more likely to buy those complete works CD packages, and they're probably more interesting as people to look at in terms of their music taste as well. So what I want to do is see if we can use some of this user data to answer another very, very important question, which is who has the most passionate fans? Is it the dubstep fan, or is it the heavy metal fan? So how are we going to do this? How are we going to try to derive fan passion? There's lots of possible metrics. You may look at which artists have the most edits on their Wikipedia page, or who's spending the most money to go to concerts. But one very, very simple metric, which I call the passion index, is essentially the average plays per fan. So here's some two artist examples. So this is completely fictitious data, just for an example. So let's pretend Robin Thicke has 200,000 fans in a particular time period, and during that period, each of his those 200,000 people plays Robin Thicke 5 times. So he hits 1 million plays, 5 plays per fan. That's kind of a low passion listener because it's only about 5 plays. The fans are not coming back very often, but he has a pretty broad base. Now take another artist, Lord, who has the same 1 million plays, but those are distributed differently. Instead of across 500,000 fans, they're distributed across a smaller fan base of 10,000 fans. And each of those fans are playing Lord 100 times. So these are much more passionate fans. Again, these numbers are totally fictitious, so I don't want to see any article about Spotify saying how this, that. So what we can do now is just look at this play data and say, which artists do indeed have the most passionate fans. So I ran this over maybe 10, 20,000 artists, and here's a plot that's showing on the x-axis the number of fans an artist has, and on the y-axis the number of plays. And so as you'd expect, you see a nice sort of rising line. As typically, as you get more fans, you get more plays as well. But artists that are sort of at the top end of the curve, these are the artists that have this high passion index. They're getting more than their fair share of plays per listener, whereas artists down here are getting less than their fair share of listeners. So we can find the artists with the high passion just by looking at those artists that are above the line and do that. So when I did that, look at the top 1,000 artists, look at their passion index, we could see who are the top artists with high passion listeners, and we can answer this question of who has the most passionate fans. So raise your hands if you think it's dubstep that has the most passionate fans. All right. What's that? Oh, it's all right. Or raise your hand if you think heavy metal has the highest passion fans. All right. It's everyone's thinking metal. All right, let's see. All right, so here's a list. Top most passionate artists, at least when I ran this data, it was In Flames. And then we have the Beatles, Radiohead, Die Arts, Medium, Self-Indulgence, Nightwish. So if you're not familiar with In Flames, this is what they sound like. We have their music there. Let's try the audio again. So they have 115 plays per fan. Obviously, why they have such high, passionate fans. And if you look at they count through the top 20 artists, 9 of them are heavy metal bands, and 0 of them are dubstep. So we indeed answered the question, heavy metal fans are more passionate than dubstep fans. But, of course, who has the least passionate fans? There's an artist out there, the top 1,000 artists, that has the lowest fan passion. They have only 5 fans per play, 5 plays per fan. Any guess? Yes, Survivor. And, you see that a lot with one-hit wonders. People will get that song in their collection, maybe play it when they go for a run every once in a while, but it's not a keeper. All right, so it's a little side story here. I was looking at fan passion last year, the end of the year song of the summer thing, and typical curve. But there's this one song that was way, way off the charts when it's coming to fan passion. And this was this song called "Miss Moving On." Turns out it's by Fifth Harmony, which is sort of an X Factor band, which is sort of the girl version of One Direction, a bunch of young ladies who are singers. And they were way off the charts, and I thought, wow, this is really cool, a big, big, big discovery. But I took a little bit deeper look, and I said, well, let's look at how many plays they're getting from their biggest fans and compare it to other artists. So if we look at like Lord and Taylor Swift and Birdie, their biggest fans play their music for this particular time period about 1,000 plays, whereas this particular artist and song was played 100,000 times, so that's 2 orders of magnitude larger than any other artist. And so I thought something's fishy going on, especially if you do the math and multiply the length of the song times 100,000, the song had not actually been released. Not enough time to do all those plays. So, and indeed, there was something going on. There was a sort of this grassroots fan network on Twitter and all the social media where they were essentially saying, go on, help get our girls' song up the chart. Stream it as often as you can, 24/7. Just mute it. You don't have to listen to it. Just play it, and get it up the charts. And it was really amazingly well organized. And so I wrote this blog post about it. And like 10 minutes after I posted this blog post, and I don't think there's a lot of teenage young ladies who read big data music blogs, but apparently some do. And like within 10 minutes later, there was a sort of Twitter backlash, and it sort of ultimately came down with me being called a creepy old man. So just a little warning here. Now, that sort of ends this sort of look at data, but we're not done with the creepy. Now we're going to look at what we can learn about people based on when they listen to music. So one of the things that we can do, because we have all this really good play data, is look at how people are playing music across different social circles. So we looked at how college students listen to music. And what this is showing here is sort of the typical day in the life of a music streamer at a college student. So we took billions and billions of plays and sort of averaged out the total number of plays at any particular hour in the day. So across the bottom is sort of the hours of the day. And so you see the peak play where people on college campuses are listening to music most is around 4 p.m. The absolute lowest is around 6 a.m. Yes, a question? Oh, because, for this particular data set, there's actually a number of ways. Some music streaming services have college deals, so we know which users have those. Some have by IP address and all sorts of things. The question was, how do we know that they're college students? It's a good question. And some will give email addresses. So I won't say exactly where this one came from, but there's lots of ways. So people listen least at around 5 a.m., and that sort of makes sense in college campuses. And you can sort of pick an arbitrary point and say, when streaming falls below sort of the 50% line, that's when people are going to bed, and maybe people are getting up when it crosses the line going the other way, so 9:30. So college students are sleeping sometime. That's sort of relative, but it's interesting when you start comparing particular universities. So I looked at users from one university, Brigham Young, which I'm not sure if you're familiar with American universities, but it's one of the more conservative universities. They have things like curfews where after 12, no visiting hours and stuff like that. And you can see just by looking at the delta between when Brigham Young University streaming drops below 50% and the rest of universities that Brigham Young tend to go to sleep about an hour earlier than the rest of the world, but they get up about 45 minutes earlier. So they're getting an extra 15 minutes of sleep. You can use this kind of streaming data to say, maybe pick your university based on the sleeping habits of our university. So that's about as creepy as I can get. But I just want to sort of raise this there is something that people who are doing big data, especially now, are trying to pay a particular attention to, is trying to look at data, how we can use the data to help people improve their music listening without crossing that creepy line. And sometimes we'll walk up to that creepy line for little experiments, but we try not to cross it. All right, so next one is, what can we learn about music based on when people are listening to music? Now this is some kind of new work that I've been doing, so it's really half-baked, freshly baked, but I think it's really kind of interesting. And the idea is to track when people are listening to a song and when they move on to another song. And if we can look at how people are interacting with their player within a particular song, maybe we can start to find within a song what are the most interesting parts of that song. So if we look at, this is looking at billions of plays, sort of what I call the song abandon rate. So when people are listening to a song, over the course of the song, people will leave the song. So they'll leave it, maybe their subway car will come and they'll go in a tunnel, or they'll get an email and they'll turn off their music to pay attention to what they're supposed to read, or they decide they don't like this song anymore and they want to move on to the next one, or some friends bump into them, or whatever reason. There's sort of this steady decay of a song, and it follows this curve here. And it's not really important to look at the numbers. It's really the shape of the curves that matter the most. But you can sort of say maybe per minute, a couple percent of people will, on average, be leaving a song for whatever reason. I'm only showing I'm sort of ignoring the first 10, 20, 30 seconds of a song, because that's a very, very different behavior, because that's where people are sort of browsing through music and skipping through fast. But once people start listening to a song, you sort of see this steady decay. And so if we look here, looking at this curve for 12 Katy Perry songs, you see how they all sort of follow the general curve. So we get an idea that, yes, this is generally true when we start to look at individual songs as well. So then, started to look at some songs in particular. So this is Phil Collins' In the Air Tonight. I'm sure you're all familiar with it. And you can look at the curve. It seems to follow the general shape. It maybe drops off a little sooner, and that's probably because it's a longer song, and so people are moving on at a faster rate in terms of the song length than average. But one of the interesting things is as we sort of zoom in, we can sort of see, instead of hitting this sort of bottom, and that the bottom of the trough, which means this is where people are listening least, there's this little trough where all of a sudden it seems like people stopped leaving the song. They were paying attention, or something was going on there, and then after that they moved on. So this, I think, is perhaps the most interesting bit of the song. So if we listen to that, we can hear what that sounds like.
No use in fooling. The hurt doesn't show, but the pain still grows. Some strangers to you and me.
Right, so when people get like 10 seconds before the drums come in, they stop, they say, all right, I'm going to listen to this bit. They don't leave the song, they get through that, and then after that, you can see sort of that big rise after the dip there. Then, all right, I got to that, my favorite part. I'm done, I'm out of here, I'm moving on to the next one. So you look at a few more songs and see this. So this is Led Zeppelin's Whole Lotta Love, and it follows a general curve, except that there's this sort of bump after about a minute and a half in here. And this is sort of an unusually high abandon rate in this song, and this is during the psychedelic interlude. I'll play that. That's this bit. So a lot of people, they're either scrubbing to the next part of the song or are moving on. But down here, this is where it really flattens out. This is where people who have made it this far in the song are essentially saying, I'm here for the rest of it. So this is like the most interesting bit, and that happens to be the guitar solo. All right, and then finally, here's a Dead Mouse song, Raise Your Weapon, and it has this really unusual curve. It has this huge bump in the middle. It's almost like it's two songs. And so we get to a spot where it's a really kind of interesting bit, and then shortly afterwards, lots of people depart from the song. But then it sort of follows a normal trajectory again, where people are still hanging around and listening to the end. So here's perhaps one of the more interesting bits of the song right here. All right, and then, oops, I didn't. So this is the bit where people are deciding, well, the song's over, I'm going to start moving on. So sorry, I lost my head here. All right, so there. All right.
And it's over. How does it feel now to watch it burn, burn, burn?
So if you're familiar with the song, you know this part of the song. The song essentially is divided in two. There's a sort of lyrical instrumental with a female vocal during the beginning, and then there's the moment where Dead Mouse goes dubstep, and he does this in tempo over the course of the song. So you see these 4 peaks here. That's showing where the song speed has increased, maybe about 5 beats per minute, and then you can sort of see it dropping off again. So we see these 4 distinct places where the song speeds up. Any idea why that might be? The chorus, yes, exactly right. So during the chorus, the song tends to speed up and slows down. So we can take a listen what that sounds like. This is right before the chorus.
In this desert that I call my soul, I always play the starring role.
And so once we hit the chorus, you can hear it sort of speed up. So you see, even over the course of these 4 peaks, the Stuart Copeland, he's getting even faster at every very chorus. So he's using tempo as one of the ways to give the song more energy and more liveliness. This tempo variation is not due to Stuart Copeland being a bad drummer. It's due to him using tempo as one of his tools to make the song come alive. Now let's compare, and you can do some math around this to assign a machine score. You can sort of see at the bottom, Stuart Copeland gets a machine score of 25%, which means he is probably not a machine. He is probably a human. Now let's compare this to a song by Britney Spears called I Love Rock and Roll. So you can see there's not very much variation at all in the song. So here's what this song sounds like. So yes, that's the machine. You can do the math. Nobody really needs to do the math. You can just look at this and see, yes, there's a very high likelihood that no human is generating this beats here. So in search of the click track, you can go here and look at any song and get an idea of whether your favorite drummer is getting some machine assistance or not. All right, so next way we can use some of this acoustic data is enhancing the listening experience. So everyone sort of experienced these music visualizers that let you get some visual to go along with your music. And they're generally driven off of amplitude changes in the music, or maybe they're doing some kind of FFT around the music. But one of the things you can do when you have sort of a really rich audio summary is do a much more high fidelity visualization. So in this particular one, against an Ellie Goulding song, it's taking into account not just really low-level beat and amplitude changes, but larger segment and phrase changes to drive a visualization. Now there's some by-hand stage management as well, so it's sort of a hybrid between human and machine generating this visualization, and you can get a feel for what it's like.
We can light it up, 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 so they can't put it out, out, out. We can light it up, 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 so they can't put it out, out, out. We can light it up, 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 so they can't put it out, out, out. We can light it up, 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 so they can't put it out, out, out. When the lights turning down, they don't know what they heard. Strike the march, play it loud, giving love to the world. We'll be raising our hands, shining up to the sky. Cause we got that fire, fire, fire. Yeah, we got that fire, fire, fire. And we're gonna let it burn, 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 burn. We're gonna let it burn, 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 burn. Gonna let it burn, 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 burn. We're gonna let it burn, 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 burn. When the lights turn down, they don't know what they heard. Strike the march, play it down, giving love to the world. We'll be raising our hands, shining up to the sky. Cause we got that fire, fire, fire. Yeah, we got that fire, fire, fire. And we're gonna let it burn.
So I built this at a Music Hack Day this year, and I realized after I actually created fan art, and it's the first time I'd ever created fan art. So I submitted it to a Ellie Goulding fan site, and nobody commented on it, so I was sad. It's hard being a fan. So this next one is inspired again by my daughter. I watch how she listens to music. She listens to maybe through the first chorus, and then she's on to the next song. So the idea is to build attention deficit radio. So for people who have very, very short attention span. So we'll make a playlist of songs and try to give you a nice beat matched crossfade between the songs. And this all is sort of done in the browser, so it's having to do all sorts of crazy tricks to make it work without time stretchers and all that stuff. So here's attention deficit radio. So we're going to start to mix in the next song. So that's attention deficit radio. So that was the idea of using some of this music data to enhance the music listening experience. So now we're going to look at using how we can use some of this acoustic data to help create new music. So once we have this notion of where all the bars and the beats and tatums are in a song, we can use this info to algorithmically remix new music. So in Echonis, we have this library that sits on top of this data called Remix, and with Remix, you can chop sounds into section bars, beats, and tatums, and then you can programmatically manipulate these pieces to generate new music. So any Python programmers out here, so here's like 6 lines of code that will take a song and extract the first beat of every bar and generate a new song. So this is essentially beat 1 version of the song, and you can hear what this sounds like for a Lady Gaga song. That's what it looks like first. Here's what it sounds like. Now here's another example of taking the same song and making a new version by playing the beats in reverse order. So it's 4 lines of code to generate a new song. So surprisingly musical, considering that we've taken a song and put it in a completely different order. My daughter, she asked me, she hears me making these hacks. She hears me listening to these Lady Gaga and said, Dad, do you like Lady Gaga? And I say, yeah, I like some of her stuff, mainly beat 1. So. So next up is Tristan's The Swinger. So this is made by Tristan, one of the founders of the Echo Nest at a hack day. And the idea of this swinger is to take any song and to make a swing version of the song. So this is, again, one of the things that you can do, since we know where all the beats are in a song and we can stretch and compress them, we can make a song, we can make a program that automatically will make any song swing. So here's the input. This is not swung. You're all familiar with that? All right, so here's a swung version. So that's the swinger. All right, so next section is all about interactive listening. So back in the 1890s, this was sort of your typical scene in American living room. Anyway, everyone had a piano or some way of making music, people would gather around and do this. Now in this digital music recording age, our ability to interact with our music is sort of down to volume and skipping. I think in the next few years we'll see maybe getting the user more in the loop. And here are a few examples of some possibilities of how that might look. So the first one is a hack called the infinite jukebox. And the idea for the infinite jukebox is for when your favorite song isn't long enough. So what infinite jukebox will do is it'll take a song and it will generate an infinite version of the song. It's always changing, it never ends. So the way it does this is it takes a song and breaks it down into the beats, uses all of the different analysis data that we have to find the beats that sound the most similar, and it builds a graph of the song connecting all the really similar beats. And then when it's playing the song, instead of playing the song in sequential order, it can start to jump around through this. So in this particular song I'm going to play, and you'll sort of see this little green bar going around, and sometimes it will jump to different parts of the song as it goes, so you'll see.
The scars of your love remind me
So as we come up to the first chorus, you'll see that's kind of connected with all the other choruses, and it'll start to jump around.
Scars of your love, they leave me breathless. I can't help feeling we could have had it all.
Now we're in the second chorus,
You have my heart
and we're back to the first chorus. Second chorus.
to the beat. Could have had it in the deep. You have my heart you played it to the beat, baby.
So that's the infinite jukebox. You can imagine some future music player having an infinite button next to the play button that would give you the play the song forever mode. So the next interactive music hack is called the Bonhamizer, and it runs under the theory that any song could be improved if John Bonham happened to be the drummer on the song. And so what it does is it takes, there's some outtakes of some John Bonham drumming sessions, and it will try to align the drums against any song. And so it's doing some beat alignment, but it also tries to do some intelligent planning to say, you don't want the drums playing all the times, but you want them to come in with a good impact. You don't want the Hammer of the Gods sort of destroying the whole song. So you can sort of get a feel for what this sounds like.
I stay up, cashing in my bad luck. Some nights I call it a draw. Some nights I wish that my lips could build a castle. Some nights I wish they just fall off. But I still wake up, I still see your ghost. Oh Lord, I'm still not sure what I stand for. Oh, what do I stand for? What do I stand for? Most nights I don't know anymore.
So again, you can imagine every player having a little, John Bonham symbol right next to the play button to give you added Bonham. All right, so this next hack, this is called the autocanonizer, and this is, the idea here is, you guys maybe know what a canon is, like Row, Row, Row Your Boat. It's a song that can be played against a time offset copy of itself. So this particular program looks at the music data and tries to build a canon automatically of any song. So it's going to find, it will play the song through normally, but it will also find parts in the song that it thinks would overlap best with that song and give you two voices instead of one. So you can hear what this sounds like. And it generally switches on the phrase level. And this visualization is showing sort of the amplitude across that, but at the bottom you'll see places where it may start to shift.
I like the dark and I think to myself, what a wonderful world. Worlds, the colors of the stars, so pretty in the sky, are so unfacing of people passing by. See a train shaking and singing, oh how someday wish upon a star. Wake up where the clouds are far behind. Be where trouble melts like a lemon drops. High above the chimney top, that's where you find me, oh, somewhere over the rainbow. Waves fly, and the dream that she did to was in no goodbye.
So that's the auto canonizer. All right, so next up is an app called Girl Talk in the Box. This runs in the web browser. You guys see that? All right. So Girl Talk in the Box gets its name from Girl Talk, the mix-up artist. The idea is that lets you play with your music. So instead of just listening to music, you can interact with it. So it breaks a song down into beats, or I can switch it to a finer grain like Tatum's. And I can just sort of do like click and play a beat. All right. Or I can start at the beginning of the song and just play it through normally. And I can interact with it just by hitting some keys. I can stop it on a beat. And I can back up the song beat by beat. I can play every other beat. Or every fourth beat. And I can make the best drops ever. So it's a way for somebody to take control of their music, to play with their music. It's actually a whole lot of fun. So I recommend you try it out. So that's the end of this 55-year-old pretending it's Skrillex. Now back, slides here. All right, so that's sort of the quick tour through the acoustic data, how we can use the acoustic data to help people understand music, to take control of their music more, to interact with their music, to play with their music. And that's also a quick look at all these 4 different types of data. So almost everything that you've seen here, they're online. Most of them are web apps. You can go, if you go to the labs.econest.com, you'll find links to them, and so you can go and try them out. And I also want to talk about the thing here. You notice a lot of the demos that we're showing here, they're very playful, they're whimsical, there's no business model behind a Bonhamizer. But it's kind of a fun thing, and this is the kind of thing that happens all the time at Music Hack Days. And so people who are really, really passionate about music and passionate about technology get together to build cool stuff. And they're not usually there to build the next startup. They're there because they really, really like to surround themselves with people who have very similar tastes and interests and build stuff. And so what comes out of these hack events are these really, really creative types of things. So there's some sessions later on today around Music Hack Day, so I encourage you, if you're interested in this sort of thing, to go. And Music Hack Day will be conducted in Berlin tomorrow and Friday, so feel free to stop on by and see what's going on there as well. So here we are in the middle of this digital music revolution. Crazy things are happening. Everyone's about a tap away from being able to listen to any song that's ever been recorded. How awesome is that? But finding exactly what song to play is going to be really important. Otherwise, you're going to be listening to that same Bon Jovi song we listened to in high school, and we don't want that. So data is going to be the key here. We can use data to help us organize our music collections, to help us understand our music better, to help us to explore for music, get music recommendations, and to play and interact with our music. So I'm really excited about the future of our big data and our big data overlords. So thank you for listening. Okay, yeah. So I think we have maybe about five minutes for questions, if there are any questions. Yes?
Okay, one moment, I'll come down.
Hello, thank you for this. It was very impressive. I have a quick question. Now that you're bought by Spotify, are all these interesting ideas still available for the competition, or is this all going to be exclusive Spotify?
So I'm a technologist, not a business or lawyerly type. The EchoNest has an open API that lets people do all sorts of things, and we continue to have that. And so you'll certainly see our API available for as long as I can foresee. So yes, you'll be able to do this stuff.
And then a quick second question. You saw the cultural data where you would grab like specific keywords from a review or something.
Yes.
What if it would say it's not fun, it's not good, it's not... Would you interpretate those data as well, or would you still pick the keywords?
Yeah, so there's a whole bunch of research around sort of these things like sentiment analysis and trying to understand the sentiment around phrases and things like that. So yeah, that's tricky, but yes, that's something we do.
Hi, thank you. I was wondering what do you think would all this analytics and big data mining, how would it affect the music production? Do you think that people would change their musical aesthetics to gain greater visibility within Spotify or other digital outlets?
So my focus really has been from the listener point of view, not the artist point of view. So there's some people here that will know a lot more, like Robert and Yuli, I think are good folks. But I certainly think that artists can look at, when they see which songs are getting popular, which parts of the song, that's kind of data that they can use. But I would hope that they would be cautious. I could imagine, I would hate to think of a 1970 Led Zeppelin deciding to omit the psychedelic part from their song because it wasn't getting traction in their focus group. And I don't think that's necessarily how music should be done. But I wouldn't be surprised if some artists do that.
I would like to have your point of view on how we could use those data to create better music, and if you foresee that as a tool for learning for musicians.
I cannot. So you asked me how to make better music using data. So I don't know. I'm a frustrated musician, so obviously I wouldn't. I think just make better music. I don't know. Sorry, I can't help you there.
Hi, Jörn from Soundrop. I think you gave a brilliant talk, so thank you. I want to ask about the fifth category of data, which is the data that someone has on a person that's not necessarily directly part of that. I mean, what you do, your behaviors online, the more kind of creepy stuff.
Yes, yes.
You could potentially use that to create magnificent playlists,
yes.
but it would scare the crap out of people.
Yes.
What do you think about it?
So I've actually written quite a bit about this. So for the long answer, go look for a blog post I did called the Zero User Interface Music Player, and maybe you've already read it. But that's something actively looking at is context. So yeah, your phone, it knows everything about you. It's kind of creepy, right? It knows where you are. It knows whether you're running, walking, sitting. It knows that you have a meeting later on with your boss who happens to like Bon Jovi. It knows all sorts of things. And so indeed, a music player that plays you the music that you like when you're commuting to work, and then switches over to playing music that you like when you're coding versus music that you like to listen to when you're dropping your kids off at school, I think is something we are looking at really, really closely. And one of the big challenges is how close to the creepy line can you get? And the problem is, of course, everybody's notion of creepy is going to be different. And so some people, when they see so you're on a first date playlist pop up on their player, are going to be totally wigged out, where other people say, oh, great, play it for me. So.
Also vielen Dank nochmal an Paul Lamere vom EchoNest hier bei der Berlin Music Week. Danke für eure Fragen und ich hoffe, es hat euch gefallen. Paul Lamere, thank you.
Thank you all.